All right, so frequency distribution. Frequency distribution means, okay, let's take a look at all of the probabilities, okay? For example, if you're going to go ahead and roll a dice, you have an equal chance to roll a 1, 2, 3, 4, 5, or 6, all right? So the probability is 1, 6, 1, 6, 1, 6, 1, 6, okay? And if I did the actual percentages, right, if I did 1 divided by 6, it's about 16.7%, okay? It's about 16.7% all the way through. So if I wanted to do kind of a distribution, like a distribution would be like a bar graph, I'd do my bar graph like this, and I'd go maybe 10%, and I'd go 20%, and I'd go a 1, rolling a 1, rolling a 2, rolling a 3, rolling a 4, rolling a 5, and then rolling a 6. And it should be completely even. My bar graph should be completely even because you have equal chances of rolling a 1. You got a 16.7%, so maybe a bar that looks like this. You have equal chance of rolling a 2 because there's only 1, 2 out of 6, right? Should look like this. You should have an equal distribution of rolling a 3, 1 out of 6, a 4, a 5, and a 6. Shh, don't interrupt. Let me teach, please. Okay, so this is a very uniform distribution, all right? All the way across, you have an equal chance of rolling a 1 as you have a 2, as you have a 3, 4, 5, or 6. Okay, that's a dice. Now, some things aren't equal, all right? For example, let's just take a hypothetical situation that we have a loaded dice. Now, some people, you know, if you're a casino, you have a loaded dice. Let's say you need to roll 6s to win, and somebody's snuck in a loaded dice, and so that loaded dice would change the probabilities. So maybe the 6 would go a lot higher. Shh, stop. Please let me teach, okay? Just listen. Don't derail me, okay? So if you had a loaded dice, meaning that it's weighted slightly different, it's a fake dice. Whoever manufactured it made sure that the weight on the 6 would always, so it's lighter, so what's on the opposite side would always pop up, so the 6 would come up more often. So you walk into a casino, you reach in your pocket, and you roll your dice, and you're winning big time because you've got what they call a loaded dice. So the probability is much higher on the 6. If we see that, we'll say, hey, wait a minute, I noticed something. I'd say, obviously, something in this distribution doesn't look right because 6s are coming up more, and they shouldn't. That guy's cheating, okay? Same thing could be true of a loaded coin, all right? So if I have a coin, and actually, coins are slightly loaded, but so little, because the heads on the corners a little bit more metal than the tails. So just something for you guys to remember, if you ever flip a coin, always pick heads. Always pick heads because about 52% of the time it will go up heads. It's not 50-50 at all. It's really 52-48 because there's a little bit more metal on the heads. Okay? Does that make sense? So if you pick heads or tails, always pick heads because in the long run, you'll get more heads than tails. Even though we say it's 50-50, if you look at a quarter, there's more metal on the top. Does that make sense? Okay? Now, so if we turn the page, and I want you to take a look at problem number 4. Okay? Let's go straight to number 4 on page 185. Okay? So, problem number 4, it says, according to surveys, 78% of women in a city watch professional football. You asked 4 randomly chosen women from the city whether they watch professional football. Okay, so what we have is 2 things. It's a binomial, 2 things. We've got 78% watch, and then we've got 22% that don't watch TV, okay? Don't watch football, right? There's 2 things going on, right? So it's the same thing as flipping the coin. It is a binomial distribution, okay? So we're going to ask 4 randomly chosen women. So what we're going to do is set up exactly what we did yesterday. We're going to go 0, C, 4. Okay, that represents 0 women out of 4 watching football, okay? We're going to set up 1 C4. Okay, that represents 1 woman out of 4 watching football. We're going to set up 2C4. That represents 2 women out of 4. Spencer, guys, will you stop talking? 2 women out of 4 watching football. We're going to set up 3C4. That represents 3 women out of 4 that watch football. We're going to set up 4C4. That represents 4 women out of 4. So this is all of our possibilities. You agree? We got 4 women. We're going to go interview those 4 women. Walk around the block. Just grab 4 women. So our possibilities are that we'd have no women that watch football, only 1, possibly a 2, 3, or 4. My guess is probably, because it's 78%, that we'd get more women that watch football. You agree with that? Now, so there's lots of combinations that could happen. I can go ring on a door, and I could get, you ready? I want you to see this. I could get, you could say, yes, I do, and you could say, yes, I do. Or, you could say, yes, I watch football. You could say, yes, I watch football. But that's the same, right? That's the same. Isn't that the same? Because I'm not going to take down names. I just got 2 women that watch football, right? Yeah. Whether I ask you first and then Kendra or vice versa, right? So it's a combination, right? And if there's combinations, we got to go to our Pascal's triangle. We go to our Pascal's triangle. We've got our 1, 1, 1, 1, 2, 3, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. There are, you ready? There's only one way that all 4 women say no, and that is they all say no. Only one way that can happen. So 0C4 is 1. 1, 4, 1. There's 4 ways that could happen, right? I could have the first gal say, yes, I watch football. Or maybe it's the second gal says, yes, I watch football. Or the third, or the fourth. So there's 4 ways that can happen, right? But it's all going to be 1 woman watching football. So I'm using my Pascal's triangle. So this is going to be equal to 4. 2, 4, 2 women. It's the 6. This represents 2 women watching football, 2 women that don't. So that's my Pascal's triangle of C. 6 combinations. 3C4 we know is 4 from Pascal's triangle. 4C4 is 1. All 4 women say yes, I watch football. There's only one way that's going to happen, okay? Now, the thing is, this is no longer 50-50%. We have 70% that say they do, and we have 22% that they don't. So I'm going to multiply it by the probabilities, okay? So then I'm going to multiply this 1. And I've got 0 that watch, right? So that'd be a 0, and then this would be a 0.22 that say they do. So I'll put that to the 4th power. And I'm going to stop for a second, and I'm going to have you write this down. And I'm going to explain what's going on, okay? And I need to put the 0.78 here. Right? If it's no longer 50-50, then I can't just use 1 out of 2, 1 out of 2. There are 2 things that are going on, but the percentage has changed. So here's how this works. 4 women, so I'm going to use the 4th row of Pascal's triangle. Okay? Now if you don't use Pascal's triangle, you can just use 0C4 and get the answer of 1. Okay? 1, 4, 1, Pascal's triangle, or you can use your notes or calculator to figure out what that is, and that's 4. Okay? So now what I'm going to do is go through and calculate the percentages. This is going to be 0.78 to the 1 power times 0.22 to the 3rd power. Let me write all these down and we'll explain it better, okay? This is a 0.78 to the 2 power times a 0.22 to the 2 power. This is going to be a 0.78 to the 1 power and a 0.22 to the, oops, I got that wrong, 3 and 1. There we go. There's a 0.78 to the 4th power and a 0.22 to the 0 power. Okay, now I'm going to go ahead and re-explain it. Write all that down. Please write the whole thing down and I'll explain what it means, okay? It's actually very easy if you pay attention. Can't make anybody pay attention. I know that, okay?
Yes,
okay. Pay attention again next year. It's okay. We'll just do it that way, right? Okay. Now, write that down and I'm going to explain what it means, all right? Write that down and I'll explain what it means. Won't disappear by June. Okay, now let me explain. So that you can set this up, Ben. Stop talking, Ben. So 4 women. Since I've got 4 people, I want every combination of 4. I want every combination of 4. Okay. So every combination of 4 is 0 women out of 4, 1 woman out of 4, 2 out of 4, 3 out of 4, and 4 out of 4. Okay, does that make sense? I want every combination out of 4. 0 out of 4, watch football. 1 out of 4, 2 out of 4, 3 out of 4, and 4 out of 4. Okay, then I need to do their probabilities. Okay, 0.78 watch, but that's 0 out of 4. That means 0.22 don't watch, so that's the other 4. Okay, 1 out of 4, I know that I've got 0.78 are the ones that watch, so there's my 1 that watch and my 3 that don't. 2 out of 4, I've got my 2 that do watch and my 2 that don't watch. Okay, 3, 4, I've got my 3 that do watch and I got my 1 that doesn't watch football. Okay, 4, 4, I've got my 4 that do watch and my 0 that don't watch. Okay, now what we're going to get are their individual probabilities. So if I were to do some kind of a random survey, this is what I ought to expect. Okay, so just using my calculator, I'm going to go straight to my 1 times 0.78 to the power of 0 times my 0.22 to the power of 4. Okay, and I get an answer of about 0.023, or about 0.2%. I've moved the decimal over 2 places. For this one, I get about a 0.2%. Okay, I'll do the same thing on this calculation. I'll go 4 times 0.78 to the 1 power times 0.22 to the 3rd power, and I get an answer of about 3%. See, I moved the decimal over 2 places. That's about 3%. Okay, that's going to be about 3%. Okay, I'll do the same thing with the 2 women that watch and 2 women that don't. I'll go 6 times 0.78 to the 2 power times 0.22 to the 2 power, and I get an answer about 17.6%. I'll round it up to maybe 18%. Okay, that's about 18%. If I take my 4, slide that over. If I take my 4 times my 0.78 to the 3rd power times 0.22 to the 1 power, I get about 41.7, about 42%. Okay, about 42%. Okay, if I take my 1 times my 0.78 to the 4th power times my 0.22 to the 0 power, I get an answer of about 37%. Okay, kind of what I expected, because the original problem said that 78% do watch football, so my probabilities make sense to me. So I'm looking at it this way. So if I randomly went around this community, let's say it's Denver, Colorado, big football town, right? Let's go to Denver, Colorado, and most women are going to watch football. So if I ask 4 women, the chances all 4 women say no, I don't watch football is pretty rare, right? Does that make sense? And then the chances only 1 woman says I watch football is pretty rare, so only 3%. If I find 2 out of 4, 18%. If I find 3 out of 4 that watch football, that's 42%. And if I want to find all 4%, then I end up getting 37%. Okay, so now we still haven't made my my histogram. To have a histogram, it's like a bar chart. So I make a histogram out of this. Okay, make a histogram out of this. I have the choice of 0, 1, 2, 3, and 4 women. This is women watching football. Okay, so I'm going to make a histogram. This is women watching football, and my percentages, let's see, I'm probably going to have to make this go up maybe 10%, 20%, 30%, and maybe a 40%, okay? All right, now, I'm going to do a bar graph. So if I do a bar graph, the chances that zero women watch football is less than 1%. I mean, it's really, really little. So I can barely going to see a bar way down here, right? Barely a bar at all because it's so little. We came up with about 0.2%, so you barely see that, okay? One woman watching football is about 3%, so that's not much bigger, but it's a little bit bigger, so my bar might be up to about there, okay? Two women is 18%, so that's going to take a big jump, right? 18% might be about there. That's about 18%. If I want 3 women, I'm at 42, which is way up here. You can see why this problem is worth so many points. 42%. And then 4 women that watch football, our percentage is about, what do we end up with? 37%, so that's about there. Okay. Now, it's about 37%. My histogram is predictable. It's predictable because the highest spot is over here, which I expected. If 78% of the women do watch football, I would expect this kind of distribution, okay? Now, what's my most likely outcome? My most likely outcome is that 3 out of 4 women surveyed watch football, okay? That is, okay? So I'm going to answer it, okay? So my most likely outcome is right here. That's the highest bar. That's the largest percentage. So I'm going to say, okay, I think that 3 out of 4, that's my highest percentage. That's what I expect that'll happen, okay? Now, lastly, what is the probability that at most 1 woman? At most, that means that'll work. That's at most, right? At most 1 woman, okay, and then 0%, right? So so 2 is more than that, right? That at most, right? So at most means 0 watch or 1 watch. So to find out, then I can include the 0%, this group, and this group. So I add their probabilities together. So what's probability at most 1 woman watches football? That would include no women and 1 woman. So that is going to be my percentage of 0.2%, because I got that from there, plus my 3% gives me a 3.2%, because I have to add the probabilities, because these gals watch, this is much more than 1, right? Okay? Now, this is tough. This is a tough lesson, isn't it? All right? So what I think we ought to do is a little bit of the homework together, all right, out of the computer. So I'm going to stop recording, okay? And